This video lesson is going to, we're going to be working with scientific notation, which we'll do a brief review of what scientific notation is, but we're also going to be focusing on how to get those numbers entered into your calculator. I will be using this calculator. You might have a different calculator. So let's just talk about what scientific notation is. Standard or regular notation is just the normal way that we write numbers. So for example, 208 million would look like this. It would look like 208 million would have this many zeros following it. 208 million. Okay. 3 thousandths, that's 3 thousandths, we have to go to the thousandths place, would look like this. 3 tens, hundredths, thousandths place. 3 thousandths is written like this. Scientific notation, right, is a short way to write very big or very small numbers. It's a way to condense the number down. It is written as the product of two numbers, right? So this first number that's before the multiplication sign, this is what is called the coefficient. And the coefficient is a number that must be between 1 and 9.9. It has to be less than 10, and it has to be greater than 1 or greater. This number after the product sign, after the multiplication sign, is what we are going to call the exponent, which is a base 10 exponent. Basically, it is, you're treating it, it's like it's a decimal. It's counting the number of decimal places because it is base 10. But what if we wanted to take a number like 280 million and write it into scientific notation? Currently, while the decimal is not visible, we know that it should be at the end of all these zeros. We can move that decimal so that it is now a number between 1 and 9.9. So we're going to move the decimal how many places over till we get a number that is between 1 and 9.9. So 2.8 becomes the number, but we can't just leave it at 2.8. We have to multiply it by some exponent, base 10, to represent the number of decimal places that we jumped, right? So this is 1, 2, 3, 4, 5, 6, 7, 8 decimal places. So 2.8 times 10 to the 8 power is the scientific notation for this. 0.003 is not a number between 1 and 10. It's much less than 1. So we need to move that decimal so that the number becomes a number between 1 and 9.9, and so we get the number 3, but we will have moved the decimal 3 places, but we need to make that a negative sign. Okay, so what is that? What is that sign? Why do we know? How do we know if it's positive, negative? What does it mean? So let's take a look at these examples to figure it out. These numbers all have positive exponents, and if we look at the magnitude of these numbers, this means that a positive exponent means that the value of the number is greater than 1. Over here, we have, oh, my dogs are dreaming over there. If you're hearing little squeaks behind me. Negative exponents. Rico, wake up. 3, we have negative exponent negative 2, exponent negative 5, exponent negative 2, exponent negative 11. When we see those negative exponents, we see that the number is less than 1. It doesn't mean, a negative exponent does not mean the number is negative. A negative exponent means that the value of the number is less than 1. Okay. Now, entering these scientific notation numbers into your scientific or graphing calculator. There's different ways to do this. Every calculator manufacturer does this differently, but you are looking for a key labeled either EXP or EE. On some calculators, the EXP button is way down here, right? So there's this little EXP right here. On this graphing calculator, there is an EE button, and I know this is super hard to see, but right here above the 7 is a key, and above that key is a second function. And it is labeled as an EE. So this calculator had an EXP button. This calculator has an EE button, and it's usually above, I think this might be a comma, but it's above the key above the 7. So it's a second function. Okay, and that means to access that EE, you're going to have to press the second function key that's up here in the left corner. Now, this is the calculator that I have. This is my favorite calculator to use in this type of a class. I feel like it's the most user-friendly of all of them. But this calculator has an EE button. It's not a second function. It's direct, just a straight-up button. It's right here. Okay, and so again, every calculator is a little bit different, but you are looking for one of those two keys, and they might be a second function, it might be a straight button, but you got to find it. Okay, so a number like 6.02 times 10 to the 23, it's a very large number. You would type it in as such. You would type in the coefficient 6.02, and here's the thing. Here's the thing. Never will you ever type in the times 10 part. At this point, when you press the EE or the EXP button, that takes the place of you typing in the times 10. When you type that EE button on this calculator, a little 00 pops up. It is waiting for you to put in the exponent. Okay? So if I type in the 23, that's what you do. This right here is the number 6.02 times 10 to the 23. A little confusing perhaps because you don't see the times 10, but that is what this is telling you. Okay. Now what if you wanted to put in a negative exponent like this number down here, 6.626 times 10 to the negative 34? Well, that's not really a big deal. You would use the plus minus key down here. So 6.626 EE, that's my times 10, and then I'm going to go negative 34, and you can see that the little negative sign popped up right there. Okay, now these are really large numbers. There's no way that you can force your calculator to show you the whole display because that would require 34 decimal places, and this calculator can't do that. But if you had a number like 2.59 times 10 to the 4th power. That's a small enough number that this calculator can display it. And if I hit equal sign, my calculator will display the value of that number. So some calculators have the ability to take these reasonable size numbers that'll fit on the display, and you can toggle them back and forth into scientific notation and out of scientific notation. For this calculator, there is a scientific function. It's in mine's in green. It is a second function. So if I want to take this number and put it into scientific notation, all I have to do is press second, and then that button 5, and now that number is back into scientific notation. This means 2.59 times 10 to the 4th power. I see now that I am in scientific mode. That means this calculator will only report answers in scientific mode, even if I press enter. So that's not always helpful, right? Because you don't always want a number in scientific notation. So to get out of scientific notation, I need a floating decimal. So that's what FLO stands for. And I can do that, and I can move that number in and out of scientific notation. So that's how this calculator works. If you have a different calculator and you're wondering if it can do those things, I can work with you in class to figure that out. But the calculator can't always help you move numbers in and out of scientific notation, so it is good to know how to do it manually. So just a couple of examples. we have these standard notation numbers. If you need to report them into scientific notation, I'll show you. Let's work through those examples. Okay, speed of light, 300 million meters per second. We'd want to make sure that this number, the decimal here, needs to move over how many decimal places so that we get a number of 3, right? And so this becomes 3 times 10. Well, how many jumps did we make, right? 1, 2, 3, 4, 5, 6, 7, 8. This is 3 times 10 to the 8th meters per second. It's going to be a positive exponent here because this number was larger than 1. The number of stars in the Milky Way becomes 2.3 times 10. Well, let's see, 1, 2, 5, 8, 11, 14, times 10 to the 14 stars. Numbers less than 1. To make this number between 1 and 10, we want it to become 1.36. Okay, 1.36 times 10. We moved it only 1 decimal place. It's going to be a negative 1 power because the original number was less than 1. It was a fraction. So this is 1.36 times 10 to the negative 1 millimeters. Our last value is 1.332 times 10, 1, 2, 3, times 10 to the negative 3 grams per milliliter. All right, notice that when we did this, the leading zeros dropped out. We've referred to these numbers when they start at 0, when a measurement starts as a 0, those are placeholders. Those zeros drop out when you put into scientific notation. We also dropped these zeros that were trailing at the end of the number because they were not considered significant. Without a decimal point visible here, that's our clue that these zeros are also placeholders and they will drop out when we use scientific notation for those values. Let's switch it up and go the other direction. Let's get a number that's in scientific notation and let's put it into standard notation. Population in Ithaca is 3.2108 times 10 to the 4th people. This is an exponent larger than, it's a positive number. So that means this number is going to move to the right 4 places. So this becomes 32,108 people. Okay, that also makes sense. You wouldn't move the decimal to the left if it's a population of people. Elon Musk's net worth. This was looked up on January 22nd, 2023. 1.491 times 10 to the 11th dollars. So what we'd want to do is we'd want to move this decimal place 11 places to the right. So currently, let's be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So putting in our commas so we can wrap our heads around that crazy number. It looks like net worth is $149.1 billion. All right. How about the wavelength of violet light? 4.0 times 10 to the negative 7. Okay, it's a negative exponent. That means I'm going to move my decimal to the left 7 places. So 0.0. Let's see, 1, 2, 4, 0. I believe that's right. So 1, 2, 3, 4, 5, 6, 7. Yes. So 0.0000004.0 meters. Okay. We had the 4.0. This was an important 0 according to whoever wrote this measurement down. So we want to maintain that. At the end. Oh, that's not a 0.0. That's just a decimal place. Atomic mass unit, 1.67 times 10 to the negative 24. Okay, so we need to go 167. That's already moved the decimal place twice. right? So now we have to move it 22 more times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Well, that's a ridiculous number, and you can see why we use scientific notation. Okay, it's a very small number. No, I did that the wrong way. Not paying attention. We got to go the other direction. 167. All right, so that's moved it one place. Now we have to keep moving it 23 more places to go negative 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so that right there is that number in standard notation. Okay, really impractical. It's obviously the reason why scientific notation exists. Now, a word about scientific notation and significant figures. When you have a number in scientific notation, this is such a lovely thing. All the digits in the coefficient of the scientific notation number are considered significant. Easy peasy lemon squeezy. Scientific notation here. There are 4 digits in this coefficient. There are 4 significant figures. 3 significant figures. 2 significant figures. Okay, you don't need to, it doesn't mean that these aren't important, right? This is holding the decimal place. But just in terms of counting sig figs, you just need to look at the coefficient to determine. We've got 1 significant figure here, 2, and 2, 3, 4, 5. I believe that's 9 if I counted correctly. So the number of significant figures there, yep, 9 significant figures. All right, in this lesson, we have learned how to, or we've learned to interpret what scientific notation means. We know what a positive exponent means. It's a number greater than 1. A negative exponent means that it's a number less than 1. We are figuring out how to enter scientific notation numbers into our calculators, and also without our calculators, being able to manipulate. It's a good skill to have. And then recognizing that all the digits in the coefficient of a scientific notation number are considered to be significant. That's it for this lesson on scientific notation. We'll see you back in the classroom.